We'll proceed in pseudo calculus problems. Okay, pseudo calculus problems, the area in which we are pursuing the discussion, we are taking example by example and we are calculating the area. Okay, so there are two branches that we have seen that integral calculus can be used. One is multiplication and one is repeated addition. Anyway, not exactly repeated addition, but similar to that. Anyway, let's take that. I have one small example. Okay, I have one small example. Consider this is x-axis. This is x-axis and there are points here. One point is 0, one point is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 points are there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. At 0, at 0, I have a height of something as 0. At 1, I have height of something. There is one vertical line is there. At 0, height is 0. At 1, height is 1. At 2, height is 2. At 9, height is 9. Okay, then what is the addition of this? I believe it is all right. From x equal to 0, x is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. At each point, I have a vertical line, vertical bar. At 0, height is 0. At 1, height is 1. At 2, height is 2. At 3, height is 3. At 4, height is 4. Like that, at 9, height is 9. In that fashion, what is the sum of all these? Anyone would say it is y at x equal to 0 or y0 plus y1, y2, y3, y4, y9 is the summation of this. If I say y is function over x, the way it looks like that, right? When x is 8, height is 8. When x is 9, height is 9. When x is 3, height is 3. Means y equal to function over x and that is equal to x. So I can say the addition is summation mark. This is summation mark. This is, I believe it is called sigma, summation mark I equal to 0 to I equal to n, where n is 9. I equal to 0 to I equal to n. Fx function over x, and I always think of referring it. Anyway, function over x, bottom right, I, fxi. That can be symbolized like this. Summation mark I equal to 0 to I equal to n, where n is 9. And then, after that, and then we have fxi, means computation addition of all fx. Okay, how much it will be? 0 plus 1 plus 2 plus 3 plus 4 plus up to 9 will be 9 into 8 by n, I'm sorry, it will be n by n into n minus 1, I think so. N into n minus 1. What will be the summation? That is, I believe it is 1, 2, 3, 4, n into n minus 1 up to uh, n. So 9 into 8, I believe it will come as 63. Someone can try. 9, 8, it will become 17. 17 and 7, it will become 24. 24 and 6 will become 30. Okay, 30 and 5, 35, 4, 39, 3 and 2, 3, 42, 44, 45, not 63. Okay, so it will become 45, I believe. Okay, I believe it is n into n minus 1 by 2. This is what I think so. Actually, I don't remember how what is the actual formula is. So it will be n into n minus 1 by 2, not 2. So it is coming as 45. Okay, or n factorial of n divided by something like that. Okay, so factorial divided by whatever it is. it is 45. So if I add, keep adding 0 plus 1 plus 2 plus 3 plus 4 up to 9. Okay, this is more or less factorial of 9. Factorial of 9. What is factorial of 9? Someone can calculate. I really don't remember the formula. But it looks like it will come as 45. It will come as 45. N minus n into n minus 1 by 2. How much it will be? 9 into 72. 9 into 8. Okay. N or 10 into 9 by 2. That is n is 10. Number of count is 10. So n into n minus 1. 10 into 9 by 2. It looks like in that fashion. N into n minus 1 by 2. Okay, how it can be? Now I have to calculate, consider that whatever, this is how it is. Means I have a vertical bar and it starts from 0 and then 1 and 2 and 3 up to 9, it goes up till 9. And then what is summation of this? Summation mark I equal to 0, I equal to n, where n is 9, and then it is fxi. Keep adding it. How this is this a repeated addition? Certainly not. This is not a repeated addition. Neither what is repeated addition then? How can I transform into integral calculus? It looks like addition of item. Addition of item. Please be aware that in books, generally it is written that summation of fxi means fx dx. Summation of fxi means fx. That's why I have brought into the picture. Whatever we are bringing, it is either confusing in the book or not available in the book. In the book, generally it will be written n equal to 0 summation to I equal to 0 to I equal to n, where n is 9. I equal to 0 to I equal to n, where n is 9. Summation of fxi is, or I equal to 0 to I equal to n. This summation is typically equal to, the summation is typically equal to fx dx if it is continuous. If it is continuous, then it is fx dx. Okay, we will clarify it. Where is integral calculus and why it can become integral calculus? What is integral calculus? Integral calculus is calculation of the area. Integral calculus is someone can say multiplication calculus. If you multiply two items, then one item will become dx and another item will become fx. Fx into x become fx dx. This is the basic of integration. When we try to calculate multiplication through the area way, if I try to achieve the result of multiplication through area by drawing the area of two operand. One operand is fx, another operand is x. We are trying to multiply fx into x. If it is like that, then it will become fx into x. I'll take 2D shape now. One side is x and another side is fx, that is the height. If I multiply these two items, I want to find multiplication of these two items, where fx means it is a function over x, it depends upon x. Means everywhere height is tied to the x-axis. In that fashion, we have to calculate this multiplication by calculating the area. Anyway, I have discrete now. I equal to 0 to I equal to n fx. Fx. Okay, in that case, how it can be transformed into integral calculus if it is really possible. Okay, what is the integration? Integration talks about multiplication of two items when one is independent and one is dependent upon them. In that sense, make an independent axis as x-axis and dependent axis like fx as y-axis. Draw the graph and then calculate the area from one limit to another limit on x-axis. Whatever the area comes, that is the multiplication. That is integral calculus. Now, if I see discrete fx, where fx is at x equal to 0, x equal to 1, x equal to 2, x equal to 9, there are bars. There is no continuous line. In that sense, Can generally it will be written in the book that summation of I equal to 0 to I equal to n fxi is same as fx dx, where limit is x equal to 0 to x equal to n. Okay, how it is, why it should not be, why it should be, that we will see now. Okay, when we are saying that fxi, summation of fxi, what we are trying to achieve. This is a trillion dollar, not even trillion dollar, multi-trillion dollar question. What we are trying to achieve? When I say that I have I equal to 0 to I equal to n, and then I'm sorry, summation mark I equal to 0 to I equal to n. Generally, it will be found in the probability stochastic theorem of signal and system, where people expect discrete signals, and there people try to assess something. In that way, if I have a summation mark I equal to 0, I equal to n, fxi, f bracket close x bracket open x bracket close, bottom right side I, small I, fxi. Okay, now let's draw it. Why to feel shame? Let's draw it. Now, when x equal to 2, then this is the height. Okay. Now, when x equal to 3, then this is the height. When x equal to 4, then this is the height. When x equal to 5, this is the height. When x equal to 6, this is the height 7, 8, 9. Okay, watch it carefully. Can I multiply any height with 1? That is the question mark. Can I multiply any item? If I say I have an item, I'm giving you 2 balls. Did you receive 2 balls? Okay. Did you receive 2 into 1 ball? Simple. If you add something with 0, then it is same thing. If you multiply something or divide something by 1, it is same thing. If you subtract something by 0, it is same thing. Okay, so in that concept, if I say that what I'm trying to achieve through this summation is fx when x equal to 0 plus fx when x equal to 1 plus fx when x equal to 2 plus fx when x equal to 3 plus fx plus fx x equal to 9. Same thing can I write again fx when x equal to 0 into 1 plus fx when x equal to 1 into 1 plus fx when x equal to 2 into 2 plus like that. Someone will say, why these are the minute things that help anyone to get to complex problems. Okay, when basic is out, then what anyone would understand. What is fx when x equal to 0 into 1? If you multiply two items, then it gives you one shape of base and height. Fx when x equal to 0 into 1 means base is 1 and height is fx at x equal to 0. Next is base is 1 and height is fx when x equal to 1. Base is 1 and height is fx when x equal to 2. Base is 1 into height, that is fx, when x equal to 3. If you keep doing like that, at the end you will end up, someone will end up in fx into 1, where base is 1 and height is fx when x equal to 9. Makes sense? I believe it is all right. Okay, if that is the case, then we are trying to calculate, we are trying to sum areas. Makes sense? Okay, when we are trying to summation of area, what summation we are trying now? We are trying summation of area. One area is one height and one width. Then another area is height and width, height and width, height and width, height and width. Looks like we are summing up rectangles. Makes sense? Okay, we are summing up rectangles. One rectangle, first rectangle is height, that is fx at x equal to 0 and width is 1. Another rectangle is height, fx at x equal to 1 and width is 1. Makes sense? So in that fashion, if I do so, then it more or less transforms into repeated addition on the x-axis of for the section that is 1 1 1 1 1 1 1, or delta x plus delta x plus delta x plus delta x. Someone can write it as fx equal to 0 into delta x plus fx equal to 1 into delta x, or fx equal to 0 into delta x at x equal to 0. Makes sense? fx 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 at x equal, or sorry, fx into delta x at x equal to 0, or fx f function over x fx I into delta xi. Here I is, now I can write the summation again as summation of I equal to 0 to I equal to n fx I into delta xi. Makes sense? Because I know that delta xi is always 1, but still I can write in that fashion. Now, if that is the case, then delta xi, delta x0, delta x1, delta x2, delta x3, delta x4, delta x5, more or less it is repeated addition along the x-axis. Makes sense? If that is the case, then if I talk about x is 0 to 9, then there are 9 segments are coming. Okay, that is as good as dx integration from 0 to 9. Makes sense? Okay, then certainly it will be transformed into, certainly it will be transformed into fx dx integration from 0 to n. If it is integer I equal, now someone can think, if I say that fxi summation, these are very big things. No one understands. Generally, it is found in the book. Summation of I equal to 0 to n fxi is same as integration 0 to n fx dx. Okay. Now, in that fashion, that is the clue where I jumps 1 1 1 1 1. I is 0, then 1, then 2, then 3, then 4. And if you anyone translate the summation to integral calculus, then portion by portion you are adding the rectangle. Okay, the area, because integration means area. Integration means area. Anyway, it transformed into this because the width portion, if I say dx, dx means that is the x-axis, and that is really x-axis because 1 1 1 1 1 1 section we are adding. Now anyone would try, if I say I equal to 0, I equal to 0 to n, I equal to 0 to n, that is true. But I moves 0.25 fxi, means fxi equal to 0 plus fxi at I equal to 0.25 or zero point 0.5, it is jumping, not 1 1 1 it is jumping. Then will it be integral calculus? Again, that is the question mark. Okay, what is question mark? Question mark is I have now 18 bars. I have 18 bars. One bar is first bar is when x equal to 0 and height is 0. Second bar is x equal to half and height is half. Third bar is x equal to 1, height is 1. Similarly, the 17th bar or whatever it will come, when x equal to 8.5, then height is 8.5. When x equal to 9, then height is 9. If I add, if I do the kind of summation in that fashion, summation I equal to 0 to I equal to n, where it jumps 0 0.5, 0 0.5, 0 0.5, not 1 1 1. fxi, will it be same as fx dx where x is 0 to 9? Certainly not. What is fx dx 0 to 9? First we will calculate the way we did. Okay, fx ds, what is fx? Fx is x. Wherever x is there, fx is that much. Fx dx, that will become x dx, that is x square by 2. Oh, it is similar. X square by 2. 0 to 9 means 9 into 9 by 2. It will more or less come as 41, 42, similar to 45. We are getting the result. Why there is a deviation? Because it is not smooth. It is a staircase. It is going like a staircase. When x equal to 0, there is nothing, then 1, then 2, then 3. It is moving like a staircase. If it moves smooth, then it will be 45. How it will be smooth? It will be more smoother if we take n equal to large. If I take n equal to 20, then what will be summation? As per our formula, what we had thought, n equal to 20 means 21 into 20 by 2. This is what I remember. 21 into 20 by 2. It will come as 210. Okay, here it will come as x square by 2. 0, 0 to 20. 0 to 20, x square by 2. 400. Say now it is coming more or less near to the result, 200. So this is all right. But if I make jump in 0.5, 0.5, not 111, if I make in that fashion, then it will not give the result what we are thinking, because we are not calculating the area, full area what we are thinking. We are calculating double of it, because the width should be 1. Width should be 1. Then only it will come under integral calculus arena. Then what is the solution? Solution, someone can think what is the solution. But if I make I jump 0.5, 0.5, and I equal to 0 to 9, 0.5, 0.5, 0.5, and then I do fxi, it will not be fx dx x equal to 0 to 1, because there we are calculating area of a triangle where base is 9 or 10 and height is 10. That is the area. If I jump 0.5, 0.5, I am making something not 10 times. It should be 10 times. 1, 1, 1, 1. I believe it is understandable. This is the called the integral calculus. Repeated summation I can take. Repeated summation I can take. But repeated summation should add up to the net x I am taking. Okay. And in that fashion, the height should be taken care. Otherwise, it will cause problem. So it must be at one step. Then only we have making it a complete triangle. Because if I am going to calculate the integral calculus, summation of fxi is same as fx dx, then we are trying to calculate this fx dx means, if the fx dx means whatever the area, if fx equal to x, then this is a triangle. We are trying to calculate area of this triangle. If I'm trying to calculate area of this triangle, then discrete bar should be spaced by one unit. Then there will be 9 unit area that we are calculating. I believe it is all right. Not all right. Not able to understand. We'll try again. If this is x-axis and I'm saying fx dx, fx dx. Okay, what is fx dx? I don't know. Fx is x. Function over x. Function over x is x. In that case, what is fx dx? That is actually equivalent to fx into x. The earlier it would have been fx into x. If it was fx into x, then it is fx. It will become fx dx. What is fx? Fx is x. If fx is x and this is origin, consider this is origin and this is x-axis. Fx is x means this will form a triangle. Now x is 0 to x to 9. It makes a triangle like this. Okay, if I say fx dx x equal to 0 to 9, this in between whatever the area is coming, of the triangle, this area I am trying to calculate with fx dx 0 to 9, where fx equal to x, it makes a slant line. Okay, now chop it at one place. If I chop it, I can chop it, right? So I can chop it. I can chop in different area. I can chop it in different area. I can chop here and then I can chop here. This area, same area. Chop here and then chop at x equal to 1. Then this area, then chop here, then chop here. That is again x equal to 1. Means width is 1. At one width, keep chopping it. At one width, keep chopping it. Okay, if you chop at one width, if you chop at one width, take one as width and keep chopping it, it will form 9 different sections, where the top section is a slant line. If you chop in many sections, then top section will be like, for every section, top will be like a flat line. approximation. Okay, now that you can bring every section is a rectangle now. If chopped section is very high, every section is rectangle now. If every section is rectangle, then we can add all these rectangle. We can add all these rectangle in a fashion, all these rectangle in a fashion that it will give the same result. I believe it is understandable what I am talking. If I am saying I am trying to calculate integration of 0 to 9 fx dx, where fx equal to x dx, where fx is x, it will give a slant line at 45 degrees. X is 0 to 9. This is the triangle I am trying to calculate area with fx dx. X is 0 to 9. This area is same as if I chop in many area and add all the triangular area. That is same thing. In that fashion, if I chop in many parts, consider I chop in infinite part, then one part if I take, then bottom is horizontal and vertical part is slant line. If it is very small, then I can take approximation that it is flat line only. Okay, in that fashion, in that approximation, the small every section I have divided into n section. Every section area is width into height, width into height, width into height. If I have chopped in 9 parts, then width is 1 and height is what we see. Width is 1, height what we see. This is what we are actually indirectly doing. I equal to 0 to I equal to n summation fx. This is indirectly we are trying to do in that way. But if I do I equal to 0 to I equal to 9, where I is jumping 0.5, 0.5, 0.5. Okay, in that fashion, we tend to add fx 18 times. Okay, that will not be the actual diagram. It will not fit into diagram what we are thinking. What it will fit it into. If I take 18 fxi, then you have to multiply each fxi with 0.5. Then it will work. I believe it is understandable. If I say I have summation I equal to 0, I equal to 0, I equal to n fxi. Now, where I is jumping 0.5, 0.5, 0.5, in that sense, I'll tend to add fx at x equal to 0 plus fx at x equal to 1 plus fx at x equal to 0 plus fx at x equal to 0.5 plus fx at x equal to 1 plus fx at x equal to 1.5 plus fx equal x equal to 2. Keep doing that till fx x equal to 9. 18 times you are adding. If you are doing, anyone is doing like this, then everywhere I am writing fx, I have to multiply with 0.5, 0.5, 0.5. Then only it will give there, because I have chopped now in that manner. I have chopped it in 18 parts and each part is 0.5. Then it will fit into this triangle. This illusion, this kind of the pictorial view must be understood before before transporting any addition, repeated addition to integral calculus. Integral calculus, integral calculus means calculation of multiplication through area. That's it. Integral calculus means you're trying to anyone is trying to calculate multiplication of two items through graphical way. If I am porting any repeated addition, multiplication through graphical way is integral calculus. If I'm trying to put a repeated addition into integral calculus, someone must understand that when we chop something, it should come in same fashion. The way I gave example, that if this is x-axis and then this is x equal to 0 to 9, I chop it into n part. One part has a length of x1, one part has length of x2, x1, x2, x3, x4, x5, up to x9, where x1 is not equal to x1 is not equal to x1 is not equal to 1, x2 is not equal to 1, x3 is not equal to 1. They are different, but summation of I equal to 0 to n xi is 9. That is for sure. If I add all the x, x1, x2, x3, x9, it will become 9. That is guaranteed. But they may not be same. Can I write summation of I equal to 0 to I equal to n xi as dx? Certainly. Okay, where xi all are different. Dx means along x-axis I am trying to add many things and their addition is same as the limit. I can write as dx. Okay, anyway, idea was to proceed in the calculation of the surface area of a circle. We will proceed on it. So the concept is that if I'm trying to calculate the surface area of a circle, then what I did is I chopped this circle. This is radius, which is constant. If this radius is constant, then radius is moving like this, and radius is everywhere same. It is not varying. Theta angle is varying. Theta angle is varying. So in that fashion, if I if I chop this whatever the circle, the radius is making circle, right? Radius is making circle. If this radius, the movement, if I chop in n part, okay, n part, one part, that is one part, then one part, then one part, then one part. We have sections now. We have section now. This is one part that I divided into. This is another part. This is another part. Like that, we have so many triangles. One part in the circle, then another part, then another part, then another part. This way, we are creating many wedges. Wedge is a shape in the circle if I cut it. Then another part, then another part, then another part. We are cutting. We are cutting in n section where n tends to infinity. If I add all the part, if I add all the part, then I get the, if I add all, this is one section. This is one section in the, this is one section. Like that, this is another section. The whole is the section. Sorry, this whole is the section. This whole is the section. So if I have n section, if I add all this, then I'll get the area of the full circle, provided I know the area of one section. Then we computed area of one section is nothing but, if this is radius, if this is radius and this is radius, if I'm trying to calculate the area of this section, I'll take a tangent from this point. If I tangent from this point, tangent is perpendicular to this radius. It will form a triangle where one side is this, and one side is radius plus some amount. Okay, if this theta is very small, very small, then the tangent more or less, if it is like this, theta is very high, then tangent will be completely away from the arc. But the theta is very small, where the tangent will be along the arc. It will shift toward the arc. In that fashion, the area of the circle is r into the tangent, r into the tangent by 2. Because area of any triangle is the area of rectangle by 2. If this is a triangle, what is the area of this triangle? If it forms a rectangle, full rectangle like this, where width is this and height is this, it will make a rectangle. Half of that rectangle is this triangle area. In that fashion, if I'm trying to calculate the area of this, then r, then then it will be r and then this tangent. Tangent height into r by 2. This tangent is more or less arc only if theta is very small. And arc is, if this theta is theta, then arc is r theta. 1 by 2 r into r theta is the area of this. Now like this I have n triangles. So the net area is 1 by 2 r square theta 1. Theta is theta 1, r is constant. Plus 1 by 2 r square theta 2. Next, okay, if I divide into many triangle, where one first triangle is I equal to 1, ith triangle. So I can say summation I equal to 1 to n, where n is infinity. Okay, in that fashion, 1 by 2 r square theta I, Actually, it is 1 by 2 r, 1 by 2 into r theta. Actually, that is the area of the triangle. But then I have to add for all. More or less, it will become 1 by 2 r square, that is constant. I can keep it out. Summation I equal to 1 to n is infinity, theta I, theta I. So theta and bottom right small I, that is the net area. So theta I, where I equal to 0 to n, and I is varying 1, 2, 3, 4, not in a fractional way, 1, 2, 3, 4. I can write it as d theta the way we talk. If the jump is 1, 1, 1, 1, 1, anyway, whatever the jump, there is nothing, this is not a function. I'm not talking about function over theta, pure theta. Okay, what are you talking about? What I'm saying that if theta is 0 to 2 pi, theta is making 0 to 2 pi. If this summation, that is I equal to 0, summation I equal to 0 to I equal to n, where n tends to infinity, infinity sections I am creating of theta, but theta 1 plus theta 2 plus theta 3 plus theta n equal to 2 pi, that is guaranteed. Then it can be resolved into integration from 0 to 2 pi d theta. Makes sense? In that fashion, the area of the circle is 1 by 2 r square d theta, integration from 0 to 2 pi. D theta is d theta 0 to 2 pi will become 2 pi, pi r square is the area of circle. Okay, we will take another example. Consider radius varies with theta. Then what is the area of circle? That's where it is important. I believe it is all right. R equal to cos theta. Up. R equal to radius varies with that theta. If this is origin, and this is x-axis and this is x-axis and this is radius, radius at the origin is 1. R equal to cos theta, radius is 1, this is origin. As theta is growing, radius start decreasing. This portion is radius now. When theta is 90 degree, radius is gone. It starts like this and it is gone. At 90 degree, there is no radius at all. It touches the origin. The radius started from here and starts shrinking, and here it becomes 0. If I continue radius more than 90 degree, then it will 90 degree, means radius is this side. R equal to cos theta. If theta grows 90 degree, it becomes negative. Radius will start becoming negative. If this radius is negative, then positive will be opposite side as per the vector fundamental. So this is the radius. So theta growing 90 degree, radius will start from here. So again it will start from 0 and then it reaches pi, then this will be radius. It will form a circle, but circle will be here. Circle will be here. It will like this. I believe it is purely visible. So when theta is 0, then radius is this much. When theta is when theta is growing, okay, okay, I believe it will be half the way. When theta is 0, then radius is full. When theta is growing, see the radius, this is the radius. This is not the center. Center is here only. Center is at origin only. This is the center. This is the center. This is not the center. Center is here only. Radius r equal to cos theta. When theta equal to 0, then this is full is radius. Okay. And then radius started shrinking when theta is growing. And when theta is 90 degree, radius came to 0. Now at the origin, radius at 90 came to 0. When theta is growing, now the radius should go in this direction, but radius is negative. Radius will come in this direction, and then radius will start from 0 and it will move like this. When theta is pi 180 degree, then radius is minus 1. Minus 1 means angle goes from 0, 0, 0. Angle starts from 0 and angle passes like this and angle become like this. When it is 180 degree, radius is minus 1, means exactly at this side. Radius at 180 degree, radius will start like this and it will proceed like this. Proceed. When angle is 180 degree, radius is minus 1. Minus 1 radius I have to take exactly other side. This will become, it will form a full circle. If r equal to cos theta, then what is the area of circle? Someone can find out. Now we have 1 by 2 summation I equal to 0 to n tends to infinity r square cos theta r square theta I. Okay, but r is not constant. Now I can say ri because radius in the ith section. Now it becomes 1 by 2 summation of I equal to 0 to I equal to n, where n tends to infinity. Radius at section, triangular section. If I make so many triangles, ith triangle radius, that is ri whole square theta I. Okay, please take it as an assignment. Someone can consider it as an assignment. What is radius at the ith component? Cos theta I. Cos theta I. R square cos theta I whole square into theta I. Okay, it will form like a cos square theta is all right. Theta I will be a repeated addition where all theta, if I add, it becomes the full 2 pi. It will become 1 by 2 integration from 0 to 2 pi cos square theta d theta. This is how summation turns up into integral. This is very, very precious, much more than $1 trillion. Generally, people calculate the summation, but how to transform into integral calculus, people do not understand. This is how it is. If any summation, any part in the summation leads to full x-axis, then that can be converted into dx. xi, that is x1 plus x2 plus x3 plus x4. If it makes summation along x-axis and it makes a full, that is up to 2 pi, then it can be transformed to 0 to 2 pi dx d theta. I believe it is all right. Or if I am doing like just fx, not x, like we have r as f theta. If I say r square, that is f theta function over theta whole square. Okay, function over theta whole square. If I add I equal to 0 to n, can I transform it into fx whole square dx or f theta whole square d theta without, even though there was no theta. Right now there is a theta. The net area computation is coming as 1 by 2 summation I equal to 0 to n, where n tends to infinity. And for each section it is ri whole square theta I. Now ri become f theta function over theta. That is the radius. Function over theta I whole square d theta. Is it same as if I simplify writing it as 1 by 2 summation I equal to 1 to I equal to n function over theta function over theta whole square. This theta I can leave. If I calculate both things in integral calculus, will it be same? The way we started this discussion, that summation of I equal to 1 to n fx. Fx is fx dx, if you remember well. Both will be same. This is very miniature. Anyway, this channel name is meaning. Meaning means miniature science. Miniature science, if you understand, then only you can crack big things. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.